Picture your neighborhood. The streets, the houses, the distance you travel every day. It feels expansive. But zoom out past your city, past your continent, until you see the entire Earth. This is our baseline for what we consider huge. Now look at the distance from Earth to the Moon. In our night sky, it looks incredibly close. In reality, that gap is roughly 238,000 miles wide. That distance is so large that you could take every single planet in our solar system, line them up edge to edge, and fit them perfectly into that empty space. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune would all squeeze tightly between our atmosphere and the lunar surface. We assume the void around us is tight and crowded. The truth is, we severely underestimate the sheer emptiness of our own planetary backyard. Look at this image of Jupiter. See that massive storm system, the Great Red Spot? You could drop the Earth inside that storm, and you'd still have room left over. The storm alone is about 2 times as big as our entire planet. Saturn is even wider, about 9 times the diameter of Earth. Its rings look like delicate bands of dust, but they contain solid fragments of ice and rock the size of mountains. Yet those massive gas giants disappear when compared to our Sun. Placed side by side, Jupiter becomes a marble, and Earth is reduced to a microscopic speck. To really understand that scale, look at Earth from the vantage point of Neptune, 4 billion miles away. We are just a single, pale pixel in the dark. Our assumption that we live on a massive central world is entirely a trick of proximity. Move just a few planets out, and we vanish. Distance is one thing, volume is another. The human brain is reasonably good at visualizing hundreds or thousands of things, but when we hit the word billion, our cognitive processing simply fails. This chart shows how a billion actually functions mathematically. 1 million seconds equates to about 11.5 days. 1 billion seconds stretches out to over 31 years. The jump in scale is staggering. Apply that math to the cosmos. As Carl Sagan noted, the total number of stars in the universe exceeds all the grains of sand on all the beaches of planet Earth. Among those endless grains of sand are hypergiant stars. These are celestial bodies so large they make our sun look like a wimpy, dying ember. The biggest star we know of is VY Canis Majoris. It is roughly 2,000 times the diameter of our sun. Humanity uses our sun as the baseline unit for measuring the cosmos. But against the true stellar scale, our primary source of light and gravity is virtually invisible. Even these colossal hypergiant stars are minor details. They are single components floating inside the wider structure of a galaxy. Imagine taking our entire solar system, the sun, the Earth, the massive void between the planets, and shrinking it all down to the size of a quarter. If you shrank the Milky Way galaxy down using that exact same scale, its diameter would stretch across the entire geographic area of the United States. This is the Milky Way. It measures roughly 100,000 light-years wide. Converted into miles, that is roughly 621 quadrillion miles of space. Inside that endless glowing web of gas and stars, you occupy an incredibly microscopic fraction of a single arm. We have to map these distances onto recognizable human geography because the raw mathematical data of our galaxy's true size breaks standard human comprehension. Despite how unfathomably large the Milky Way appears, it is actually considered a runt in the wider universe. This is NGC 6744. It is a neighboring spiral galaxy with a structure very similar to our own. However, it stretches over 200,000 light-years across, making it twice as massive as our home galaxy. We capture these distant structures using instruments like the Hubble Space Telescope, stationed in orbit around Earth. Every time we build a more powerful lens to look outward, we find that our assumed maximum scale was only a fraction of what is actually out there. This is the Hubble's Deep Field, a single snapshot containing thousands of galaxies. Each glowing smudge holds billions of stars and planets. Because light takes time to travel, some objects here are displayed exactly as they formed 11 billion years ago, near the Big Bang. And that incredibly dense image represents a microscopic patch of an otherwise blank area of our night sky. We live inside an 11 billion-year-old framework of hypergiants, expanding galaxies, and endless distance. Against that backdrop, our everyday problems, our delayed trains, and our canceled television shows carry absolutely no weight. Realizing our absolute insignificance on a cosmic scale is not terrifying. It is liberating. The pressure of daily life fades away when you realize just how small our world truly is.